Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 28 on the topic atomic structure. Let's move on to the assignment. Here the first question, in hydrogen spectrum, the discharge tube contains hydrogen gas at dash and high potential difference, right? While explaining of experiment of hydrogen spectrum, we use it to use discharge tube, right? So whenever the hydrogen gas is present in the discharge tube, the pressure should be low and the potential should be high, right? There is two conditions, one is low pressure and another one is high potential. At there, if you pass the beam of light through the discharge tube, that hydrogen gas will emits. So this spectrum is, the hydrogen spectrum is emission spectrum. So in this spectrum there are two conditions, one is in the discharge tube, one is low pressure, another one is high potential difference. So the correct option is first option, that is low pressure. Let's move on to the next question. Here the question is, the hydrogen spectrum contains a number of dash, right? We know that hydrogen spectrum is an emission spectrum. That means the electron will first excite into higher levels. For example, this is n equal to 0, n equal to 1, n equal to 2 and n equal to 3. So there is an electron in n equal to 1 level. Whenever a beam of light strikes to the electron, this electron will excite to the higher levels. This electron will excite to the higher levels. So at this excitation level, the electron will release its energy, lose its energy, and even it emits to the ground state, even emits to the first level, even emits to the second level and third level, right? So whenever this electron emits to the different levels, it will show the spectrum. The spectrum is present in group of lines like this. Right? So the group of lines. So the hydrogen spectrum contains the number of group of lines. So the correct option is second option. Clear? Let's move on to the next question. Here the question, which of the following is correct? Which of the following is correct? They have given in the options wavelength. They have given in the options wavelength. So in hydrogen spectrum, the wavelengths are calculated by the Rydberg formula. Wavelengths are calculated by Rydberg formula. Rydberg formula, right? That formula is the nu bar equal to 1 by lambda equal to capital RH into 1 by n1 square minus 1 by n2 square. So by using this formula, we can calculate the wavelengths of hydrogen spectrum. So the correct option is first option. Let's move on to the next question. Here the question, in Rydberg equation, just now we have discussed, generally Rydberg formula used to find the wavelengths of hydrogen spectrum, right? In Rydberg formula, that is nu bar equal to 1 by lambda equal to RH into 1 by n1 square minus 1 by n2 square. There RH is dash. RH is generally called as Rydberg constant. So the correct option is first option. RH equal to Rydberg constant. Let's move on to the next question. So the question is, the value of RH is. So RH is Rydberg constant, it has some value. That value is That value is RH, capital H, equal to 1,09,677 centimeter inverse. So this is the Rydberg constant value. So the correct option is third option. I hope you understand well. Thank you very much.